Hey guys, so today we're going to use our calculators and I'm going to show you how to do the integrals on your calculator. I'm going to show you two ways. One's more accurate, but the other one, it might give you the idea of what an integral actually means in a graphing position, okay? So the definitive integral is written with an upper and lower limit. So before, remember when we were just doing the integral of a function and we added c at the very end? That's because we had an indefinite one, because it went on forever. But when we have a definite integral, it means we have boundaries. We have a lower limit and an upper limit. That lower limit will always be a, and the upper limit will be b. Okay, so see how this looks. This shows you that we're actually going to come out with a value. We do not need a c for this. Okay, now before I get into how to do that algebraically, again, we're just going to focus on the calculator and see what happens. Okay. So we're going to do this two ways. We're going to do the calculate menu, which means we're going to put it into Y1 and graph it first and then find the value. And then we're going to do the math menu integral, which is what we've been doing with the derivative. Okay. So when you get your calculator, of course, and like guys, I just ahead of time, I set my window here to do all of the problems that we're going to be doing on this page. So if you want to do it, do it. If not, just make sure you get your graph in the window. So I'm going to go to y equals. First thing I'm going to do is put in my function, which is x cubed minus, oops, I do that every time, don't I? Minus 6x. Okay, now I'm going to graph it. Sorry for the glare, guys. Maybe if I cover that a little bit, right? Okay, now my lower limit says -3, my upper limit says 1. So what we do, remember, is I go to the calc. My calc is in blue, so I'm going to go second, trace. I go down to my integral. And now my lower limit is going to be -3, enter. And it goes to my upper limit, so I'm going to press enter. Oops, I didn't mean that. Go back. Let me start that over. 7. And go down here. There we go. Lower limit. What did I do before? Oh, I just put in the value. -3. Upper limit, I'm going to put in the value 1. And then as you can see, what it's doing right here is it's shading. It is shading the area from our curve to the x-axis between -3 and 1. Do you see that? You can probably zoom in to look at that a little bit closer, but I'm going to keep my window the same. And as you can see, we get the value of 4. Okay, it's right there at the bottom. So let's do that with the next one. As you can see, we're in the same function, which is awesome. So let me cover that up there. So we're going to do that again. Second calc. I'm going to go down to the integral. Remember, I just type in. So lower limit is -√6, enter. Upper limit is second square root of 6, right? And as you can see, my integral, my value is 0. Okay. So again, it's shading that area between the curve and the x-axis between negative square root of 6 and square root of 6. So we're going to do this again right here. We got to change our function. It's the absolute value. So actually, I'm just going to insert because that x cubed minus 6x is still the same. So insert, go to math, number, absolute value. Oops, I guess that didn't work. Math, number, absolute value. X cubed minus 6x. Okay, graph that. Now that makes sense, right? Because absolute value is supposed to make everything positive. So whatever was negative is flipped up. Now we are going second calc. and we go down to our integral, and we're going from -5 to 5. And as you can see how it's shading under the curve from -5 to 5 to the x-axis, and we get 198 point, and how many decimal places do we go out? We go out 3, so 5, 0, 1. Very good. Now it says here though, that the calculator integration, right? It's actually more accurate for you to do the math menu. Okay. Now, sometimes our area could be negative. It could be positive. As you can see, it's 0 right here, which means it cancels out between the negative and positive. This will make more sense later, I promise. But think of the area between the x-axis and the curve. Okay, so first of all, if you are working with a TI 83 or below, which I've asked you multiple times, please don't, please go to an upper one. When you do your integral, you're going to set it up with your commas where an X is, and then our lower boundary or upper boundary. But for those of you with TI 84s and above, we're going to do this the math way, okay, which is more accurate. So if we go math and go down to our integral of our f of x, okay, now I'm actually going to type this in. So we're going from -5 to 5. Now we could do our absolute value, that's fine, but I remember I have this in y1, right? So I'm going to go vars function y1 because I already have that, and we're in x's, and then I'm going to press enter, and it's going to take its time and calculate. So as you can see, I get 198.500. Now, this is more accurate than this one. Okay, so what I recommend, always use your math menu. Okay, always use your math menu. I wanted to show you the graphing because I wanted you to see what it looks like. So that's what we're going to do as we go along. But usually what I want you to do is go to your math, just like you did your derivative, and fill that in, press enter, and you're all set. Okay, try some of that out.